1. Melting glaciers trigger volcanic eruptions, a chilling chain reaction. 2. Melting ice caps awaken dormant volcanoes, climate change's hidden threat. 3. Melting glaciers could trigger massive volcanic eruptions, new study reveals alarming link. 4. Antarctica's melting ice, unleashing a volcanic time bomb. 5. How melting glaciers could spark more volcanic eruptions. 1. Melting glaciers trigger volcanic eruptions, a chilling chain reaction. Imagine a world where the melting of glaciers doesn't just raise sea levels, it also sets off a chain reaction of volcanic eruptions powerful enough to reshape our planet. That's the alarming scenario scientists are now warning us about. But here's where it gets controversial. Could the very ice that has long kept these volcanoes in check be the key to our future survival, or our downfall? Scientists have uncovered a fascinating and potentially catastrophic link between melting ice and increased volcanic activity. Ice acts as a natural lid, exerting pressure on magma chambers deep underground. As glaciers and ice sheets melt due to rising global temperatures, this pressure is reduced, allowing magma to build up heat and pressure. When finally released, these eruptions can be far more explosive and destructive than ever before. One of the most significant concerns lies beneath Antarctica, home to over 100 volcanoes buried under thick ice. As global temperatures continue to rise, this ice is expected to melt within the next few decades. The removal of this immense weight could trigger a cascade of volcanic eruptions, releasing massive amounts of greenhouse gases like carbon dioxide and methane into the atmosphere. This could accelerate global warming, creating a dangerous feedback loop. To illustrate this phenomenon, let's look at a study conducted by Moreno-Yager and his team at the University of Wisconsin-Madison. They examined the Macho Chachuenco volcano in Chile's Andes Mountains. Their research showed that as ice layers diminished, the pressure on the magma chamber decreased, leading to more explosive eruptions. This finding suggests that the real source of danger from melting glaciers might not be just rising sea levels, but the potential for a surge in volcanic activity. Historical data supports this theory. About 26,000 to 18,000 years ago, during the last ice age, volcanic activity in the region was minimal due to the extensive ice cover. However, as the ice began to melt around 13,000 years ago, volcanic explosions became more frequent and intense. This historical pattern underscores the critical role ice plays in regulating volcanic pressure. The implications of this discovery extend beyond Antarctica. Countries around the world, including the United States, New Zealand, Russia, and parts of the Himalayas in India, could face similar threats as their glaciers continue to melt. The warning isn't limited to one nation. It's a global issue that requires urgent attention. So, what does this mean for us? Should we be scared? While the prospect of widespread volcanic eruptions is certainly alarming, it also highlights the interconnectedness of our planet systems. As we work to mitigate climate change, we must also consider the broader impacts of melting ice on geological processes. This research underscores the need for continued scientific investigation and global cooperation to understand and address these complex issues. After all, as we peel back the layers of ice, we might just uncover the keys to our planet's future. What do you think? Is this a wake-up call we can afford to ignore? Share your thoughts in the comments below. 2. Melting ice caps awaken dormant volcanoes. Climate change's hidden threat. Imagine a world where melting ice caps don't just raise sea levels, but also awaken dormant volcanoes, unleashing a cascade of environmental disasters. This isn't a hypothetical scenario, it's a reality that scientists are grappling with. Recent research from the Chilean Andes suggests that the melting of ice caps can lead to increased volcanic activity, potentially creating a devastating feedback loop in the climate system. But here's where it gets controversial. Some volcanoes in Antarctica could not only melt ice from beneath, but also release climate-altering materials into the atmosphere, leading to a series of long-term climate feedbacks. So, what exactly does this mean for our planet? The impact of melting ice on volcanic activity. Researchers at a scientific conference in Prague presented findings that underscored the role of ice caps as natural lids on volcanoes. According to University of Wisconsin-Madison geoscientist Brad Singer, when thick ice melts, it can trigger significant changes in volcanic activity. Singer and his team studied the chemistry of rocks at 6 volcanoes in the Chilean Andes, documenting how volcanic eruptions increased when ice melted during the most recent ice age. This process is akin to opening a pressurized bottle. As the ice load is removed, the dissolved gases in the magma are released, potentially leading to explosive eruptions. The research focused on what happens after ice melts, offering insights into the many volcanoes currently buried beneath Antarctica's vast ice sheets. In fact, over 100 volcanoes lie hidden under the West Antarctic ice sheet, a region where warm ocean currents are already melting floating ice shelves. The ice sheet over these active volcanoes can amplify both glacier and volcanic volatility. As Singer noted, removing the ice rapidly increases the frequency of eruptions, which could then melt the base of the ice, creating a self-reinforcing cycle. Volcanic activity and climate feedbacks. The relationship between ice caps and volcanic activity isn't new. Scientists have studied this dynamic in Iceland since the 1970s. The weight of the ice can alter the composition of magma, leading to more explosive eruptions once the ice is removed. Moreover, volcanoes erupting beneath ice release heat, trapping carbon dioxide into the atmosphere, as seen at Iceland's Katla volcano. Additionally, the weight of water from melting ice sheets could increase seismic activity by driving hydraulic pressure in the Earth's crust, similar to the effects observed around reservoirs. The future of volcanic activity. While the research highlights a potential negative feedback loop, with increased eruptions accelerating ice melt and sea level rise, it also poses critical questions about the timing and impact of such events. The response of volcanoes to ice melting is not immediate, and the variability in different types of volcanoes means that predicting eruptions is complex. As University of Oxford volcanologist David Pyle noted, this new research strengthens the evidence linking ice loading and volcanism, but more work is needed to fully understand these dynamics. The call to action in a world where climate challenges are mounting, understanding the intricate relationships between ice caps, volcanoes, and the climate is crucial. This research underscores the need for continued scientific inquiry and public awareness about these complex systems. As we move forward, it's essential to consider the long-term implications of these findings and to support organizations dedicated to climate research and reporting. So, what do you think? Should we be more concerned about the potential for volcanic eruptions due to melting ice caps? Share your thoughts in the comments below. 3. Melting glaciers could trigger massive volcanic eruptions. New study reveals alarming link. Imagine a world where the melting of glaciers and ice caps, driven by climate change, could trigger a series of explosive volcanic eruptions. This might sound like a plot from a disaster movie, but it's a real concern according to recent scientific research. When glaciers and ice caps melt, they release the immense pressure that has been weighing down on underground magma chambers. This reduction in pressure can make volcanic eruptions more frequent and more explosive. While this phenomenon has been observed in Iceland, a unique island situated on a mid-ocean tectonic plate boundary, a new study from Chile offers some of the first evidence of a similar surge in volcanic activity on a continental scale following the last ice age. But here's where it gets controversial. The research suggests that the ongoing melting of ice caps and glaciers, primarily caused by the burning of fossil fuels, could lead to a resurgence of volcanic eruptions. One of the most significant risks lies in West Antarctica, home to at least 100 volcanoes buried beneath its thick ice sheets. As the world continues to warm, these ice sheets are very likely to disappear over the next few decades and centuries, potentially unleashing a wave of volcanic activity. Volcanic eruptions can have both cooling and warming effects on the planet. On one hand, they can temporarily cool the Earth by releasing particles that reflect sunlight back into space. On the other hand, sustained eruptions can pump large amounts of greenhouse gases, such as carbon dioxide and methane, into the atmosphere, leading to further global warming. This could create a dangerous feedback loop, where rising temperatures cause more ice to melt, which in turn triggers more volcanic eruptions and even more warming. Pablo Moreno-Yager, A researcher at the University of Wisconsin-Madison led the study, which was presented at the Goldschmidt Geochemistry Conference in Prague. The team conducted their research in the Andes, camping among active and dormant volcanoes to gather data. They focused on a specific volcano called Macho Chashuenco, using radioisotope dating to determine the age of volcanic rocks formed before, during, and after the last ice age, when a 1,500-meter thick Patagonian ice sheet covered the region. Their analysis revealed that the thick ice cover suppressed volcanic activity between 26,000 and 18,000 years ago, allowing a substantial amount of magma to accumulate deep underground. When the ice began to melt around 13,000 years ago, the pressure on the magma chamber was released, causing the gases within the magma to expand and leading to explosive eruptions. The composition of the magma also changed during this period, becoming more viscous and explosive as it melted crustal rocks while eruptions were suppressed. We found that following deglaciation, the volcano started erupting much more frequently and with greater intensity, said Moreno-Yager. The composition of the magma also changed, becoming more viscous and explosive. The study suggests that this phenomenon is not limited to Iceland, where increased volcanic activity has been observed, but could also occur in other regions, including Antarctica. Other areas, such as parts of North America, New Zealand, and Russia, may also warrant closer scientific attention. Previous research has shown that volcanic activity increased globally by 2 to 6 times after the last ice age, but the Chilean study provides some of the first detailed insights into the mechanisms behind this increase. Similar phenomena have been observed in eastern California through the analysis of rocks. However, and this is the part most people miss, there has been relatively little research on how the climate crisis is affecting volcanic activity. Scientists emphasize that more research is critically important to better prepare for the potential damage caused by volcanic eruptions and to understand the possible climate-volcano feedback loops that could exacerbate the climate crisis. For instance, more extreme rainfall, another consequence of climate change, is expected to increase the likelihood of violent explosive eruptions. What do you think? Is the potential link between climate change and increased volcanic activity a cause for concern, or is it just another natural process? Share your thoughts in the comments below. 4. Antarctica's melting ice. Unleashing a volcanic time bomb? A hidden volcanic menace. Climate change could unleash hundreds of explosive eruptions. A groundbreaking study has uncovered a chilling connection between global warming and heightened volcanic activity, raising alarms about the potential for widespread eruptions as glaciers melt. Researchers warn that the rapid disappearance of ice sheets, particularly in West Antarctica, could trigger hundreds of violent volcanic events worldwide. This discovery, based on geological data from Chile's Andes Mountains, reveals how retreating ice removes the immense pressure that normally holds back underground magma chambers, making eruptions more frequent and explosive. The same mechanism observed in Iceland may now apply to other glaciated regions globally, with Antarctica's vast under-ice volcanoes posing the greatest risk. From ice to fire, the unseen chain reaction beneath our feet. Presented at the Goldschmidt Geochemistry Conference in Prague, https://Goldschmidt, info/Goldschmidt/2025/meeting app, CGI/paper/30438. The study highlights how glaciers act as natural dampeners for volcanic activity by compressing magma chambers beneath the Earth's surface. As global temperatures rise and ice melts, this pressure relief allows trapped gases in magma to expand rapidly, leading to explosive eruptions. Historical evidence from the end of the last ice age shows that regions like Chile experienced a surge in volcanic activity, offering a grim preview of what could unfold as modern glaciers vanish. Antarctica's ice loss, a warning sign. Since 1992, Antarctica has lost 3 trillion tons of ice, with the West Antarctic ice sheet, already vulnerable to warming, covering at least 100 buried volcanoes. Scientists caution that the collapse of this ice shelf could unleash massive volcanic activity, creating a dangerous feedback loop. While eruptions might temporarily cool the planet by releasing sulfate particles into the atmosphere, persistent volcanic activity would release greenhouse gases like carbon dioxide and methane, worsening global warming. Beyond Antarctica, a global volcanic risk. Though the focus is on Antarctica, regions like North America, New Zealand, and Russia are also at risk. The study urges scientists and policymakers to closely monitor glacial areas and prepare for potential climate-volcano interactions. More research is now deemed critical to understand how rising temperatures might interact with Earth's geologic systems, which could have far-reaching consequences. A call for urgent action. Despite its significance, volcanic activity remains underrepresented in climate models. Experts stress the importance of incorporating geological responses into climate risk assessments. As glaciers retreat and ancient volcanoes emerge, Earth's reaction may not be subtle. It could become a loud, explosive, and globally disruptive force. But here's where it gets controversial. Should we prioritize mitigating volcanic risks alongside traditional climate solutions? What would happen if we ignored this hidden threat? These questions demand your thoughts. What's your take? 5. How melting glaciers could spark more volcanic eruptions. Brace yourself. Melting glaciers might not just be a symptom of climate change, but could also become a major driver of destructive volcanic activity around the world. And here's the twist. This feedback loop could actually speed up global warming, making an already tough problem even harder to solve. Scientists are now sounding the alarm about a hidden danger lurking beneath thick layers of ice. They've discovered that as massive glaciers in places like Antarctica, Russia, New Zealand, and North America shrink due to rising global temperatures, the volcanoes beneath or near them are poised to erupt more often and with greater ferocity. This fresh warning comes from a comprehensive new study unveiled at the 2025 Goldschmidt Conference in Prague, which looked at the volcanic history of 6 southern Chilean volcanoes during the last ice age. Here's where things get controversial. For decades, researchers have suspected that melting glaciers might increase volcanic eruptions, but only recently has detailed evidence begun to back up this theory. Lead researcher Pablo Moreno-Yager from the University of Wisconsin-Madison explains, glaciers naturally tamp down volcanic eruptions because of their massive weight. But as they retreat, that pressure is suddenly released, leading these volcanoes to erupt both more frequently and more violently. How does this work? The science is surprisingly straightforward, yet the implications are sobering. When thick glaciers sit on top of volcanoes, their immense weight essentially locks in subterranean gases and molten rock. Think of a heavy lid holding pressure inside a pot. As the ice melts away, the crust and upper mantle lose that downward force, allowing gases and magma to expand rapidly. This dramatic shift kicks volcanic activity into a higher gear, and these more frequent, explosive eruptions can have serious local and global impacts. Just look at what happened in Iceland, an often cited example that underscores the potential scale of this phenomenon. About 10,000 years ago, as the last ice age ended and glaciers across Iceland melted, the island saw a staggering 30 to 50 times increase in volcanic eruption rates, according to studies published in the early 2000s. Such enormous surges fundamentally reshaped the landscape and altered atmospheric conditions. But here's the part most people miss. While the effect in places like Iceland is well studied, the threat posed by volcanoes buried under continental ice sheets elsewhere remains vastly underexplored. This is why the Chilean study is so important. It fills in crucial gaps about how volcanoes react as glaciers recede, using advanced methods like measuring radioactive argon in magma rocks and analyzing the crystals that form during eruptions. The Chilean team's findings are striking. Between 26,000 and 18,000 years ago, while the Patagonian ice sheet blanketed the region, volcanic eruptions remained relatively minor, allowing magma to slowly gather beneath the surface. Once the ice melted, all that pent-up pressure was unleashed, leading to powerful eruptions, such as those that created the now dormant Macho Chashuenko volcano. And the threat isn't just local, it's global in scale. One 2020 study identified at least 245 potentially active volcanoes worldwide that lie underneath or within 5 kilometers, about 3 miles, of glacial ice. Could these regions be next? Moreno-Yager cautions, the real risk comes when you have thick ice covering a magma chamber, and then that ice starts to recede, suddenly releasing the pressure. This exact scenario is already unfolding in parts of Antarctica. North America, New Zealand, and Russia could also be at risk and deserve far more scientific scrutiny. Here's where the debate heats up. Are increased volcanic eruptions good or bad for the climate? In the short term, volcanic eruptions release sulfate aerosols that can actually cool the planet by reflecting sunlight, a phenomenon linked to temporary cooling spells and even historical famines. But over the long term, scientists warn, the greenhouse gases emitted by frequent eruptions could add up, fueling further global warming. As Moreno-Yager puts it, multiple eruptions over time could produce enough greenhouse gases to accelerate climate change, creating a dangerous feedback loop. Melting glaciers trigger eruptions, which in turn speed up glacier loss. So, what do you think? Is this feedback loop an inevitable part of our warming world, or do we have a chance to break the cycle? Should more resources be devoted to monitoring glacial volcanoes in vulnerable regions? And do you think volcanic eruptions could ever help slow down warming, or is that idea just wishful thinking? Share your thoughts and join the debate below.